Okay, we're going to talk about electron, or how to draw electron, sometimes called Lewis dot structures. And so a Lewis dot structure is just basically a symbol. So the symbol, and then it's surrounded by valence electrons. So valence electron are electrons in the highest energy level. And so the order in which we put the electrons around the symbol is we have the s orbital to the right, and then we have the 3 p orbitals above, to the left, and below. And hopefully that'll make more sense as we do a problem. If I take a look at oxygen has 8 electrons. I first have to write, or what I'm going to do is I'm going to do the orbital diagram. So here's the orbital diagram, and then here is the corresponding electron configuration. So what I want you to see is we first have to determine the valence electrons. So by looking at this particular electron configuration, the highest energy level is energy level number 2. So just to remind you, if I write 1s2, the 1 is my energy level. So therefore the highest energy level is 2. 2 is the highest number here. I have 2 types of electrons in the second energy level. I have 2 s electrons and 2 p electrons. So, 4 p electrons. So there are 4 electrons in the p orbital. This gives me a total of 6 valence electrons. 2 of them are s, and 4 of them are p. So 2 plus 4 gives me 6. All right, so now I'm ready to write my symbol, or my electron dot structure. I'm going to do something in the intermediate, but then I'll go ahead and show you exactly what it looks like. So here are my orbitals. They surround the symbols. The symbol for oxygen is O, and then I'm going to go ahead and put my orbitals. What I'm going to do is I'm just going to correspond it to the orbital diagram. So here of my s, I have 2 electrons, they're up and down. And then I have 3 p orbitals here, here, and here. I'm going to fill them in. So if you look here, I have 4 electrons, 4 p electrons. So I'll put one here, one here, one here, and one here. So you can kind of see how these 3 that I just filled in correspond to these 3 here. Okay? Now, this is not the electron dot structure, but I'm just showing you how we get those electrons, or where they come from. What I have to do now is I have to take those electrons and I'll make them dots. So here I have my s orbital, 2 electrons, so I put 2 dots like this. Here I have my p orbital, I have 2 dots. In fact, what I would do is I would go 1, so I have 4 p's. Here's 1, 2, 3, and then 4. Okay? And that's how I would get it. So that's oxygen. All right, so on your own, try silicon, and then I'll show you how to do it. So you can press pause. So silicon has 14 electrons. So what I do is I just write out the electron configuration. So if I look, I now identify my valence electrons. Here's my 2 highest energy levels. I have 4 valence electrons, 2 s's and 2 p's. So I'm going to go ahead and set this up. In the middle is the symbol. I have 2 electrons that are s, and then 1 p here and 1 p here, right? Because remember, I have to put the electrons on different orbitals. So that'd be silicon. Okay? Try titanium on your own, and then I'll show you the answer. So go and press pause. So titanium has 22 electrons. Its electron orbital or electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. 2, 4, 10, 12, 18, 20, and 22. So that's correct. All right. Now this one's a little tricky because if you look carefully, the highest energy level is this 4. And so I only have 2 valence electrons. Because I only have 1 4, and that there's 2 s electrons there, so valence electrons. So this would be titanium, and then 2. And that's it. The next question that comes up is if you look at, like, say, oxygen, what you'll notice is that, or any, around the symbol or any element, around the symbol, you can only fit 1, 2, 3, 4, 5, 6, 7, 8. It looks like the maximum you can fit is 8 valence electrons. And why is it that we only have 8 valence electrons? And so the way I would explain it is this. If you look at the electron configuration in Aufbau's principle, what you'll notice is that the s and the p orbitals they are the only ones orbitals that are valent. And why is that the case? Well, let me just go through the electron configuration. So you have 1s2, 2s2, 2p6, 3s2, and 3p6. If I stop here and I draw my Bohr model, here's my 1s2. On my second energy level, I have 2s2, so here it is. Here's 2p6, 1, 2, 3, 4, 5, 6. So right now I have 8 valence electrons, right? And we're saying the maximum is 8 valence electrons. 2 of these, I should have used different colors. So 2 of these are the s orbitals, and 6 of these are the p, or from the p orbitals, right? Now, our next is going to be the 3s, right? And so if we go, here's my 3s2. And so my 3s2 has 2 electrons that are valent. Now, what I have circled in green and yellow, they're no longer my valence electrons. Why? Because I now have 3, I now have a third shell, or a third energy level, which is my higher. So now these are my valence electrons. I have 1, 2, 3, 4, 5, 6. That's 3p6. That's what I have so far. So currently I have 8 valence electrons in my third energy level. So if we remember, if you use the diagonal rule, the next rule is 4s2. So now these no longer are my valence electrons. I now have these are my valence electrons. I have 2. So even though after 4s2 I have 3d10, so what I'm going to do is I'm going to go back into my third energy level. I'm going to start filling these electrons. Even though I'm filling these electrons, what I want you to notice is they're not affecting my valence electrons. They're not affecting these electrons. And so that's why the reason why the d and the f orbitals don't play a role in the valence electrons is because the d orbitals are always filled in after the previous, or the new energy level. So for example, my fourth shell, or my fourth energy level, is already my valence, so I'm basically backfilling these d orbitals in the third shell. They play no role because there's already a new energy level that's opened up. So no matter how many electrons I add to my third energy level, I can add as many as I want, it's not going to affect the fourth energy level, or my valence electrons, because there's already a higher energy level that is acting as my valence energy level. I hope that helps. I know it's slightly confusing, but if we kept on going, our next one would be 4p6. So here's 1, 2, 3, 4, 5, 6, and then as soon as you reach 8, the next one will always be a new energy level. So new one opens up. Now these no longer are my energy. Those are no longer my valence. This is my new valence shell. And so once we reach 8, a new shell always opens up. That's how the pattern seems to work. Just from practice on Bohr models, or not Bohr models, sorry, Lewis structures.